This learning target is pretty straightforward. There's an expression that relates the period of a mass on a spring system to the mass and the spring constant for that system. Now, one thing that's worth noting on here is that the amplitude of vibration does not appear in this equation. So whether we stretch that spring a little bit before we release or a whole bunch before we release, the period is going to be the same. Now, the exception there, of course, would be if you stretch a spring too far, a real spring anyway. If you stretch a real spring too far, it's going to become overstretched and it won't go back to its original shape. It might change the spring constant if you stretch it too far. But assuming that that doesn't happen, which is an assumption we make for an ideal spring, then the period doesn't get affected at all by the amplitude. So, using that equation, let's figure out what the spring constant for this system would be. So here we have our mass is 5.0 kilograms. We have, let's see, completes one oscillation in 3 seconds. The time for one oscillation is the period, 3 seconds, which gives us the idea that frequency, which has to be 1 divided by the period, that must be 0.33, etc. Not seconds, but hertz. Though now that I look at that, I don't know why I bothered calculating that, since we don't need it. And the question is, what's the spring constant for the system? So we know that T is equal to 2 pi times the square root of m over k. So we're looking for k in this one. So I'll start by dividing both sides by 2 pi. Divide by 2 pi. And that cancels out there. So T over 2 pi is equal to the square root of m over k. Now I'm going to square both sides. And I get t squared over 4 pi squared is equal to m over k. I'll multiply both sides by k to get t squared over 4 pi squared times k is equal to m. And then I'll divide both sides by t squared over 4 pi squared to get that k will equal, let's see, dividing by a fraction, I can just multiply by the reciprocal, so that'd be 4 pi squared m over t squared. So then k is 4 pi squared times the mass, which is 5.0 kilograms, times the period, which is 3 seconds, squared. And so k then is going to be, type that in here, 4 pi squared times 5 divided by 3 squared is 9, and we get 21.9. Then be kilograms per second squared, or that's the same thing as 21.9 newtons per meter. Remember, a newton is a kilogram meter per second squared, so if we get rid of one factor of meter, we divide newtons by meters. We're left just with kilogram per second squared. But newtons per meter is the unit we typically use for spring constant.